So hope everyone so everyone can turn on their webcam so we can take a group photo. So Carol, boleh tolong assist for the photo session? Jo?
Ya.
Wait ada lagi.
Kita tunggu lagi ada yang masuk.
So hope everyone can turn on their webcam to have more interaction session today. And also we are waiting for everyone to turn on their webcam to have a photo session. So hope everyone can turn on their webcam so that we can have more much more livelier session. Okay.
Okay.
Kejap wait Alah, ramai lagi tak buka ni jom.
Ramai yang tak buka.
Okay. Boleh ambil gambar dulu. Okay.
Okay, kita akan ambil gambar ready for page 1 ya. Hold on. Ready? 1, 2, 3. Okay, page 2. Ready? 1, 2, 3. Last page.
Ada.
Last page. Okay, last page. Ready? 1, 2, 3.
Okay. Thank
Okay.
you, Joe.
Right.
Okay, thank you. Hope everyone can keep their webcam turned on while we're having our session today. Just a few ground rules before we start. Hopefully everyone can keep their mic muted. However, if you have any questions, you can just raise your hand and just interrupt the session. Is it okay, Mr. B, for them to interrupt the session if they have any
No
questions?
problem. No
So
problem.
if you have any questions, just interrupt the session and ask your
Yes.
question. And also we have a chat room for you to drop your question there. Then our moderator today will read the question to our speaker today. Okay. Bismillahirrahmanirrahim. Assalamualaikum and very good morning everyone, and welcome to MWA monthly tech talk on planning guideline and best practice handbook for water supply system series 6 section 7 topic water treatment plant layout and general arrangement. So I would like to introduce our speaker today, Engineer Beh Hong Lin, who is a registered professional engineer Malaysia and a chartered UK engineer of UK. Has more excuse me. He has more than 40 years experience in planning, design, implementation, and contract administration of large-scale water treatment plants throughout the Malaysian Peninsula. His area of expertise includes planning, feasibility, and detailed design of water supply schemes, water treatment process, pipelines and pump stations, project management and contract administration. He is now an independent consultant who has a degree in Bachelor in Engineering of Civil from University of Canterbury from New Zealand. So now I would like to introduce our speaker and pass the session to our speaker, Mr. Beh. So Mr. Beh, the floor is yours. You can start your session today.
Thank you, Dr. Carol. Good morning, everyone, and thank you for taking the time to attend this Tech Talk number 6 on chapter 7. I'd like to share my screen first. Okay. Can you see the screen now? Dr. Carol, can you see the screen?
Yes, I can see the screen.
Okay. All right. Let's get on with it. This section 7 is on water treatment plant layout and general arrangement. First of all, I would like to highlight that this best practice handbook is not a technical, not to be confused with the technical guideline, because I think Splash has not Splash pula. Sorry, my mind's not working this morning. I think the authority is coming up with a technical guideline on the treatment plant design as well. They have published a previous technical guideline on pipeline and distribution system, and now they are publishing a technical guideline on water treatment plant design. So this is not the technical guideline. It's just a design guide and a best practice reference based on the experience of all the article contributors. And so through this technical talk, we would like to invite feedback from everyone, either through Q&A session today, or you can submit your queries or advice through email to MWA, so that we can further improve the next edition of this guideline. Okay, just as an introduction, the water treatment plant is like a heart of the entire water supply and distribution system. It's the water quality and quantity control center. So the process elements and the support facilities shall be carefully selected and sized so that will result in an efficient operation of the treatment plant. The layout of the treatment plant shall cater for any future extension, normally based on the water demand. We will size the treatment plant for maybe the demand in a few years, 2-3 years time, because the construction will take about 1 to 2 years. And then we will see what's the rate of increase of the water demand, and maybe allow for extension for another 10 years demand or something like that. So if you don't do that, then when the demand increase, then you have to look for another site for the treatment plant. So normally we design treatment plant on a greenfield. Sorry, on a greenfield we allow for space for future extension. And we would like to stress that the poorly designed water treatment plant will affect the efficiency and effective performance of the plant, leading to deterioration in water quality and quantity, and also an increase in the operation and maintenance cost. It is also never easy nor economical to carry out modification or improvement works on an existing plant. If the plant is not designed properly and you need to modify it, it will always cost money, and it's also disruption to the operation of the plant. Okay, location of the treatment plant. During planning, these are the few principal factors that we need to take into consideration when locating the treatment plant: the planning of the plant design, site selection, and the environmental factors. On the planning side, this is a significant factor. The location should cater for the present and future demands, as I mentioned just now. And it could take into account also the possible growth of the service area, which is the delivery area, and the potential deterioration of the source quality. Sometimes the source, raw water source, could be in a region of fast development, and there could be a potential deterioration of the water quality. And so in our planning, we got to allow for possible addition of future treatment process to cater for that. In trying to locate the treatment plant, we should look at the master plan of that area, if one is available. If there's no master plan, then we got to discuss with the local authorities, looking at any new application for developments, and discussion with the Ministry of Environment and other stakeholders as well. in planning, the engineer's concern is always with the efficiency, the reliability, safety, and economical operation of the plant. Whereas the clients is more looking into satisfying the regulatory requirement. And sometimes there are factors beyond the control of engineer, like the client may have their own preference with land acquisition, so they may prefer certain site, and sometimes to satisfy some political consideration. These are the factors beyond our control as design engineers, but it has to be identified early so that you don't choose a site and go ahead and do SI and survey, and then somebody will say, no, that place has been earmarked for further development. So we are trying to avoid that. The plant design, the land selection has to consider various space needs. That means you not only the layout of the treatment plant, you got to consider the construction, during construction, the movement of construction traffic, storage of the building materials, things like that. And also during the operation of the treatment plant, what are the various space needs, like the transport of chemicals, this and that. And also the environmental requirements to be met. So the next thing is to prepare a prelim layout. I remember those days we don't have AutoCAD. I used to cut out the Manila cut. If you people know what is a Manila cut, a colored Manila cut to approximate size of a process unit, approximate size of admin building, chemical building, etc., and then try and lay them out and roughly get a feel of the size required. So, and then we got to evaluate the potential site, looking at the topo map, some of the existing constraints, etc. All these got to take into consideration. Sorry. And as I said before, the prelim design got to include present and future requirements, see whether any extension required. And all these have to bear in mind that we have to include access roads, setback means, and then any possible earthwork, cut and fill, landscaping, etc. Table in the guidebook, table 7.1 give a rough guide for smaller treatment plants. What are the area required? This guide exclude the sludge treatment requirement, and the quarters also is not included. I must stress that this table 7.1 is a very old guide, because with the new technology of treatment now, sometimes the treatment units will require a much smaller footprint. That means the whole treatment plant can be smaller. So, and for large treatment plants as well, depending on the source water quality, some may require very complicated treatment process, and footprint can increase. So this is only a guide and not cast in stone. Okay, I hope it's my hope that somebody can in the design committee can have a look at the latest development of the big treatment plant and see what's the land area required for those large plants, and come up with a guide that covers a bigger treatment plant. Site selection. There's a few factors to be considered. I think it's 7 or 8 factors to be considered when we want to select a greenfield site. That means a new site. The relation to intake and service area. So if you have your raw water source, you have your service area. So the treatment plant can be located. It could be near the river, near the water source, whether river or dam, or it could be near the service area. or somewhere in between. Ideally, we would prefer a shorter raw water main because raw water main requires much more maintenance because like things like slime growth, silt deposition, muscle formation, etc. will require the raw water main to be maintained more often, like pigging the raw water main and chlorination of the raw water main to disinfect if necessary. So preferably we will try to locate the treatment plant nearer the raw water source and have a longer treated water main. The next point to be considered is the elevation and pumping, because energy cost is a major operating cost in the operation of the treatment plant. So the elevation of the treatment plant has to be within the delivery head of the raw water pump, because normally for our river water source we use a submersible pump, so they have a limited head. So the treatment plant has to be within that delivery head. And also the location of the treatment plant should be able to supply to the service areas with minimal of pumping. Ideally, gravity flow is the best, but if not, then it have to be with minimal pumping. Site topo. Site topography. We should select a location where the slope should be ideally between 2 to 8%, so as to suit the hydraulic profile of the treatment plant. As you know, water flows from high point to low point. So if the selected site is steep and with a long slope, that will require extensive cut and fill to fit in the treatment plant. On the other hand, if it's a very flat land, it requires some cutting and filling to back in order to suit the hydraulic profile. I have here some example of the fill plant that I have designed. This is Semambu treatment plant. This is my first project. We are lucky that this treatment plant is along a Kuantan bypass, so the access is no problem. And the site is very ideal, sloping from the east towards the west, with only maybe about 2%, so that we can put the inlet mixing chamber, the flock tank, set tank, filters on the eastern side, and the filtered water will get into the clear water tank on the western side. The clear water tank is sunken, so this is a very ideal site with space for the future extension. But the aerial photograph now, you can see the extension has been built. Okay. And for one of our treatment plant in Hilipera, this is more ideal in the sense that it has a slope of 6%, if I remember correctly. So it's very ideal with minimal earthwork, but we can still have the high point for the aerator.
Mr.
Sorry.
Beh, sorry Mr. Beh.
Yeah.
Link tu kita tak dapat tengok, Mr. Beh.
Oh, foto tak dapat tengok?
Tak dapat tengok. Maybe Mr. Beh boleh stop share first.
Okay.
Then share on the screen.
Oh, I see. Macam tu.
Okay,
I try and sorry about that. Let me see whether I stop share and then share screen again.
Yep.
On the photograph. Okay. All right. Boleh nampak sekarang?
Okay.
Sorry ya. Okay. This is the Hilipera treatment plant site. As I say, we have the original ground there for aerator. So these are not filled up. These are original ground. And so you can see there's a minimal earthwork here, except the access road, and that we may need to have some cut here. And okay, also gonna stop share every time. Okay, sorry, hold on. So this is another photo that I would like to share. In that, this is a very flat area in Johor. So you can't help it. if the general topography is really flat, so some of the structure has to be on silt and steel columns and beam support. As you can see here, the aerator, the raw water inlet, flock tank and clarifier has to be on support. So this is what you do on a flatland like that, and you can think of what you do below for the space below the in between the stilts. Or some consultant may decide to if the foundation is good, then they will just fill up the ground so that the front part of the treatment plant can be sited on a field ground, and the clear water tank, etc., can be on the cut ground. Okay, geotechnical. The other aspect which is quite important to be looked into is the geotechnical aspect. Normally, we will carry out some form of soil investigation and some drilling to be carried out once the site has been selected to understand the subsoil properties, because any presence of rock will affect the cost of the construction, or low bearing capacity soil will also increase piling cost. High water table, etc., will require dewatering. So all these will increase the construction cost. So it's it's prudent to carry out some form of soil investigation on selected sites. This money we cannot be saved. Okay, flooding. Yeah, another factor to be considered is the possibility of flood. For treatment plant, it may not be, because you select it on a high ground, so it may not be a factor, but it still has to be checked so that it makes sure it's above the 1 in 100-year flood level. And if we don't have the records, the hydrological records, then we can speak to the locals nearby and learn from their experience where is the maximum flood level, or from some visual inspection also we can see some could be some watermarks and all that and things like that, so that we know what's the maximum level experienced. So okay, I won't share these slides. Yeah. Access is another essential consideration, because if you don't want the treatment plant site to be selected deep in no man's land, and long access has to be constructed. So if possible, it should be preferably near existing main roads, so that construction traffic is more feasible. So it should be considered to be accessible for construction traffic of workmen, materials, and equipment. And also during after completion, when the treatment plant is in operation, it should be accessible for your operating staff, for your trucks supplying chemicals, for your treated residuals to move out of the plant, etc. So when we select a site, we should look at the accessibility. And not only that, if you're near to existing road, or if the plant should be preferably near to the existing township also, so that the social needs of the operating staff can be met, like schooling, rubbish collection, etc., can be met. Okay. Next factor to be considered is the power supply and telecommunications. We should try and locate the treatment plant where there's a power supply can be available, telecommunications is available. For power supply, preferably we would need a dual power supply sources. That one we got to talk to the TMB or in Sarawak and Sabah, the electricity board, so that we would look at the possibility of tapping from two sources, so that if one side is down, they can still supply the power from the second intake. Otherwise, if it's only a single source, then we should look at the generator backup. So we may need to install diesel generator as backup. And then also we got to decide whether how long is the power outage going to be as promised by the power authority, so that the size of generator can be accordingly sized, whether to power up the whole plant or to power only the essential services. Land availability. Once all the requirements for a site has been established, we should check the availability of land and doing the prelim survey on the topo map. And the potential site has to be inspected on ground. And you should select a site with the least LA problems and costs. We should avoid land with multiple owners, because some of the land could have 5 or 10 owners, and you may have problem if one or two of the owners refuse to sell the land, then you have a problem with the LA. Environmental factor. So the EIA has to be carried out for your proposed treatment plant site, depending on the land size. I think DOE has certain requirements for a certain, below a certain size, EIA report may not be necessary, but if it's exceed a certain size, then we have to conduct an EIA study. For an EIA study, there are various factors to be considered, and I only pick up the main point here. We could consider during construction, the noise of the construction traffic, the dust, the traffic movement, all this got to be taken into account. And after completion, during operation of the plant, also there will be some noise generated from the pumps, etc., dust generated, and also any odor from chemicals. And we should look into the possible leak of chemicals, and what are the dangers it can pose, and what are the contingency plans to contain them. The other thing to look at is the discharges of the wastewater, of the residues from the plant, etc. So all these has to be included in the EIA report. The plant layout. In the plant layout, we should define the specific process elements, that means the treatment process units and all the other support facilities required. Layout of the plant should be as simple as possible, with the minimal numbers of process units, but yet still able to provide sufficient standby capacity. That means you don't want to have too many numbers of clarifiers or filters than necessary. So a typical treatment plant comprises the process unit, which are the aerator if required, mixing chamber, flocculation channel, clarifiers, filters, etc. And then you have the clear water tank and your treated water pumping station. And you have to consider storage for the wash water, which is required for backwashing of filters. And of course, you have the administration building, chemical storage buildings, and other M&E like electrical buildings where your incomer is, and your control centers, etc. So let me share this screen on. Oops, sorry. So as I come back to this slide, which shows the component of the treatment plant. You have the aerator, the inlet mixing chamber, flocculation channel, clarifiers, and the filters, and the clear water tank, and the treated water pumping station, administration building, and the chemical house. Arrangement of treatment facilities. In the treatment plant, it typically it comprises a series of hydraulic structures, as I mentioned just now, all the hydraulic structures, and water flow lines or connection pipes, the chemical lines, chemical dosing lines, and your chemical preparation and dosing facilities. Yeah, you have your M&E equipment for plant operation like pumping facilities, the electrical networks, instrumentation and SCADA in your control center. So in a typical treatment plant layout, the chemical storage, preparation, and all the dosing equipment are located at one end of the plant. As you can see from the photograph just now, at the end of the filter gallery, the chemical stores are located separately. This will result in long lines of chemical lines to the dosing point. We can't help this because it's not quite economical to have a separate chemical facilities at each dosing point. Like your inlet, you require alum and pre-lime, and you put an alum store there, and then at your clear water tank where you need chemical chlorination, you put a chlorine store there. So all your chemical buildings are separated and smaller, so it may not be economical, except for a very large plant. In some very large water treatment plant, then they may have a separate chemical buildings at the front end of the plant and also at the back end of the plant. So basic considerations for the plant layout is hydraulic design and connections. We should aim for gravity flow. I think mostly in the treatment plant, we have all from the inlet to the clear water tank is all gravity flow, and all connection between the treatment units shall be direct and as short as possible to minimize head loss. And once your hydraulic section has been determined, and so all the components of treatment plant can be located within the site, select your ground level so that you don't sacrifice any aesthetic requirements with minimal cut and fill. As I mentioned just now, if you have a flat site, then it requires modifications by some cutting and filling. And for cut slopes, a rule of thumb is normally 1 to 1.5, and for fill slope, this is 1:2. These are just rule of thumb, and still need to be confirmed by the SI result. Inspection, operation, and maintenance. We should aim for the easy operation and O&M for the operators. When you plan out the treatment plant, you should have efficient operator movement. That means area requiring more attention, like your chemical preparation and dosing systems, your filters where you need to do backwashing. All these have to be located as close to each other as possible, and also near to the operation building. If these areas are too far from the operation building, sometimes operators may be reluctant to go to the place often enough. So that may affect the operation. The other considerations, there's a list of other considerations in the guidebook, but I think about 9 of them. But I'll summarize them here to say that adequate access has to be provided. It means the right way should be walked enough. You don't want the too narrow walkway. And there should be easy access from the ground to the top of the structures, like from the ground level to the top of your clarifiers or filters. There should be some easy access. There should be covered walkways where possible, and external concrete steps or galvanized mount-steel ladders. I think now operators prefer concrete steps than ladders. And also, when in our planning, we should separate the noise emitting building, like your pump station, your what you call the electrical transformer, all this will emit sound. So these buildings shall be separated from the main operating center as far as possible. And there should be adequate washing facilities with good pressure for washing of tanks and filters. These are often overlooked. I think, all these tanks need maintenance. The flock tanks, clarifiers, filters need to be washed down on a preset time so that the things doesn't grow on the walls of the structures. So you need this, we call it service water. So there should be with sufficient pressure and sufficient quantity for washing. Future extension. We have to consider the need for future extension, as I mentioned earlier. To meet the future demand, we have to allow space for future extension if possible. And also we need to allocate space for additional treatment process if we can anticipate the raw water quality to deteriorate in the near future, so that we can add in if you foresee there could be an increase in the iron and manganese level in the raw water quality, then we may have to allow for additional process of dosing potassium permanganate or other chemicals to confront this problem. Chemical dosing lines should be as short as possible to minimize clogging. But as we said previously, sometimes this is not possible as the chemical buildings are located at the other end of all the process units. So some of the lines, like to the aerator, could be quite long. But we should design the route to be as straightforward as possible to minimize clogging. And the dosing line should be arranged neatly in the trench or the trays. If it's in the building, it can be on trays. Outside, in between process units, it should be in a trench properly covered, and they should be properly marked or tagged, so that for easy identification during maintenance. Generally, the UPVC pipes are preferred, except for lime, where the operators may prefer a clear plastic where you can see whether there's any clogging or not. Sanitary facilities. We have to provide a proper and good sanitary facilities for the operators in the plants, and they should be designed to eliminate any potential contamination. But now with in the guidebook, it's still mentioned about soak away pit, but I believe nowadays most of the treatment plant we don't use soak away pit anymore, except maybe some very rural areas, some very remote areas in Sabah, Sarawak. So we have all these sanitary facilities have to be properly designed so that there's no potential leakage and contamination with the water treatment plant. And sufficient toilets has to be provided, one to each isolated buildings if possible. Places like your treated water pump station, your gut house, chemical buildings, etc., should have sufficient toilets. Of course, in the admin building, there should be male and female toilets, and the number will depend on the size of the plant and the number of operators as well as visitors. The other important factor to be considered are the overflow facilities. So sometimes these have been omitted in the design of the treatment process units. We should provide adequate overflow for the treatment units at various points of the treatment, because sometimes you may need to shut down some treatment process units, and this may cause the hydraulic levels to vary, and then you definitely need a place to overflow. Otherwise, it will overflow on the side of the structure, which is not ideal. So the overflow have to be shut safely to the suitable water course. and we should check the capacity of the receiving water course so that it should be big enough to cater for the overflow. If required, then some upgrading and protective work have to be carried out to make sure we don't flood the receiving water course as well. For steep outfall, also we need to have a suitable outfall structure to dissipate the energy, so that you don't scour the outfall area. External works design criteria. Okay, this for the external works of the treatment plant. The access roads. Access road and service road has to be metalled with a premix bearing course to standard GKR road design. The access road has to be 5 meter wide pavement with a gradient of not exceeding 9%. This is quite critical in the sense that chemical delivery truck sometimes has difficulty climbing steep roads, and if you design too steep access road, they may not be able to climb the hill, or they may have to shed some load and do double work. So the main access road should be have adequate grass shoulder on both sides. The service road inside the plant can be slightly narrow at the 4 meter wide pavement with a precast concrete road curbs on both sides. And the minimum turning radius got to be looked into and properly designed. Minimum turning radius stated in the guidebook is 15 meter. Sometimes this can be even more, depending on the type of delivery truck that's expected to deliver the chemicals. And all buildings have to be set back 1 meter minimum from the road, not from the paved surface. This has to be exclude the width of the roadside drain as well. Yeah. And also for cul-de-sac or dead end roads, we have should have a adequate turning area, so that to make sure the truck can turn around instead of backing all the way out. Parking and hard standing area, the space to be provided for the plant operators has to be provided for plant operators and visitors as well. So the size of the parking will based on the staff strength, and also sometimes the regular visiting O&M personnel, and also the number of visitors anticipated. Landscaping apply to all treatment plants. Criteria will include close turfing on all open areas and cut and tree slopes. So last time I remember when the previous requirement when we first started work is flat land has to be spot turfed, and the cut slope has to be close turf. But now it seems we require close turfing on all areas. But trees and shrubs on road shoulders, if possible, we should plant a lot of trees and shrubs on road shoulders to make the thing more aesthetically pleasing. I have some photos here, but this stop sharing and keep sharing may not be what do you call it? It will take some time, so I'll probably skip some of the photos. Okay, at the entrance of the operation buildings and around treatment facilities is also good to plant some flowering plants or fern, but we must bear in mind you should avoid trees that will have leaves falling into your process units. So we don't want that to happen. In front of the admin building, you should have some, at least 3 flag poles for the national flag, state flag, as well as the operators' flags. And you should have a signboard at the main entrance of the plant. I think this is a requirement, standard requirement now, is a big signboard at the main entrance of the plant. But bear in mind the landscaping design has to avoid any underground services like your electrical cables, chemical dosing lines, etc. Plant drainage. For surface water in the treatment plant, and also for the overflow. All this has to be catered for. The wastewater flow, the spillage from chemical trucks, and scar flows from plant facilities. All this also has to be captured and properly drained away. So the precast concrete drain has to be adequately sized, and manholes has to be provided also, so that all these can be discharged into a nearby watercourse or retention pond or your sludge lagoons. The drains shall have a minimum size of 9-inch, which is 225 mm, and a minimum gradient of 0.5%. And manhole has to be provided every 40 meters. Sorry. And if the gradient of the drain exceeds 30%, then yes, cascade drain has to be designed for with a well-defined outfall. As I said, at the end of the cascade drain, you don't want this flow of water to scour the bottom part. So it has to be a proper outfall structure for energy dissipation. Water reticulation system within the plant also has to be provided for, so that you have water for use in the operation building, in the chemical facility for preparation of chemicals, and also fire hydrant has to be provided. Well, this is a very controversial thing, because some will say that with plenty of water everywhere in your clarifier filter, you can always dump a pump in and provide water for firefighting. But anyway, to satisfy BOMBA, we still need to provide fire hydrants and also the washing facilities and the operators' quarters as well. They need treated water. The water shall be taken from your clear water tank or your treated water pumping main. And the pipe shall be cast iron, ductile iron, UPVC, or even GI. The security and fencing gate around the plant. So the treatment plant shall have a 3-meter high galvanized small steel and a PVC coated chain link fence. This is as I say, is from the old guide. From the new one will have some may prefer some anti-climb fencing, which I can share here. Please stop share screen. Can you see? So these are the anti-climb fencing system now, instead of the chain link fence. Of course, we may not need this sort of a heavy barbed wire. Probably a few strands of barbed wire will do. Oops, sorry. Okay. So besides the fencing with barbed wires, we need to have a 5-meter wide main gate of a chain link mesh or the anti-climb fencing, and also a 1-meter wide as access service gate should be nearby the main gate. So because sometimes you may not want to open the main gate, just for person access, you just use the 1-meter wide service gate. If quarters are provided, they have to be fenced separately from the main treatment plant. But their fence height can be shorter, with only a 1.5 meter high chain link fence and a 3-meter wide access gate. Guard house with a toilet facility shall be provided at the main entrance gate, that's for sure. And other requirements may include a motorized gate for ease of operation, security lightings to be provided, CCTVs, as well as telecommunication with the guard house. Okay, that's all for the design of the plant. Let's look at other factors like the structural design. I think all structures has to be have to design based on the latest structural design codes, building bylaw to satisfy building bylaws and safety regulations, and also, of course, they have to satisfy geotechnical conditions where piling are required, and we have to use piles, etc. The hydraulic structures has to be RC definitely, and I mean, but for some smaller plants or package plants, then this guideline may not be applicable. So for larger plants, normally we use RC tanks, and all these RC tanks has to be designed to water retaining structure design code and not the normal building code. So the roof of buildings shall preferably be a RC flat roof sloped to fall, and the quarters, if provided, has to be to GKR standards. So now with the new GKR standards, some of the quarters could be like a flat or apartment style, multi-story, 3 or 4 stories to save space. So architectural design, the plant layout and the structures shall be aesthetically pleasing, simple and economical. And the input architect, I think if it's needed, if it's required by the owner, then we may have to rope in an architect to design the structures. This may be applicable only to very large plants. The other considerations is the safety, which is very much stressed upon now. Besides fire hydrants, as mentioned just now, fire extinguishers shall be provided in all buildings. And for larger plants, smoke detectors and alarms has to be provided as well. But so far, I haven't seen plant with a what you call sprinkler system. The other safety aspect for operators will be height ladders. For vertical ladders, where there's more than 6 meters high, they should have a safety cage or hooks, so that if they fall, they have something to catch, and also they will fall vertically down and not backwards. So walkway around the process units shall have handrails on one or both sides. I think this one has to be provided now, not like last time. If you go to visit the old treatment plants, the walkways on the filter tanks and the clarifiers are without handrails, and you have to make sure you don't lose your balance. So now for new plants, the walkway has to have a handrail at least on one side, if not both. Similarly, the external stairs and ladders has to have handrails. And manholes around the plant has to have a galvanized mild steel grating or cover. Precast concrete or cast iron covers also can be accepted. Manhole in the roads must have heavy duty covers for traffic loads. So the other safety aspect is for the hazardous chemicals, where the emergency eye wash and shower has to be provided, so that if accident happen, then they can quickly have a shower or wash their eyes. First aid equipment have to be provided in most buildings. Water treatment plant finishes. The finishes, I think in the guidebook, there's a long list of type of finishes to be followed. Finishes has to be aesthetically pleasing, durable. Sorry, there's a mistake there. Durable and easy to clean and maintain. The guide in the guidebook shows in the various locations what should be the finish for the wall, the floor, the ceiling, skirting, etc. So I'm not going to repeat all this. You can read it out in the guidebook. And the last thing to consider is the plant utilities, which is the water supply, as we mentioned just now, which should not be a problem in a water treatment plant. Telecommunications now, I think is most people are using handphones now. So besides the telephone or intercom, handphone is a convenient way of communicating. Fans and air conditioning. In places of the operation building where people will spend a long time indoors, air conditioning should be provided. And also for equipment, temperature sensitive equipment in your computer rooms and things like that, then we need to provide air conditioning. Whereas for other buildings where only occasional attendance is required, then we can it may be sufficient to provide fans. Sanitary waste disposal, I think this has been mentioned just now. We got to look into the proper sanitary waste disposal, all this the septic tanks locations, and have to be dislodged regularly, and if possible, then we connect it to the municipal sewer network. Electrical power supply, yes, I think this has been mentioned as well. It has to be discussed with the power authority to make sure there's a reliable power supply. Otherwise, we need a generator backup, a diesel powered generator backup. Okay, that's all, folks. I think thanks for your attention. I know it's all very wordy and could be quite dull. I try to share some photographs, but that's the most I can do. So any questions, please speak up. Okay, I'll stop sharing and get back to the organizer. Get back to you, Dr. Cairo. Dr. Cairo, sudah missing nih. Any questions? Yes.
I will take from here, Ruby here.
Okay, Ruby.
Hello everybody. Assalamualaikum. Apa khabar? I think the presentation ends early.
Yeah.
So if you have participants have any question, they can ask or just put it in the chat box. Okay, Mr. Beh also can refer to the chat box. Okay. So there's one question, the first top one, longer treated water main contributed to an RW, asked by Mr. Lam Song Chun. From Jebab, yeah.
All right. As I say, this is very, I would say this is very controversial. Some would prefer a longer treated water mains. As I say, the raw water mains require more maintenance, but I agree with you. Longer treated water mains will not only face possibility of NRW and also losing the chlorination, the residuals. So there are pros and cons to be considered. If NRW is a major concern, I mean, in terms of compared to your cost of maintaining the raw water main, then we should try and site the location of the treatment plant closer to the demand areas. That's a good point. I mean, it all depends on project by project basis, I think.
Okay.
So I hope we can discuss further if need be. The answer to the slides can be provided. I will try and include some of the pictures inside and get MWA to give it to MWA for distribution.
Yeah, I can't see any more questions here from the chat box, Mr. Beh. Anything else you want to share, or participants, you're welcome to share.
To unmute and ask questions.
Turn on your video, so we can see you. It's more lively and more engaging to discuss lah.
Hi, Dr. Beh.
Okay.
Zaki here from Sungai Muni.
Hey, Zaki. Hello.
Just two questions. One is for the chemical mixing. What is the preference? Is it for the is it hydraulic mixing, mechanical mixing? That's one question. For the chemical mixing lah. And the other one, the second question is for the buildings. Is there a provision for workshop lah, for the maintenance people to have their own workshop lah? Is it a norm now, or is it based on the client request? What is the direction for the workshop? Thank you.
Okay, all right. For the chemical mixing at the front end of the treatment plant, isn't it? That's your question, isn't it? I think traditionally we prefer what they call hydraulic mixing, because a drop of say a drop of a 300 or 600 mm should generate sufficient turbulence to mix the chemicals. But now with the advance in the design of some of the mixers, which doesn't consume much energy and whatnot, so the design trend is towards a mixing tank with a submersible mixer to flash mixer to stir up the chemicals. So it all depends on the I mean, if it's a gravity flow, say your raw water source to the treatment plants by gravity. So if you have sufficient height, you don't mind losing that additional 300, 600 mm by creating a flow over the via to mix chemicals. But if it's a pumping cost that's of a concern, then you may not want the extra 600 mm height of pumping every time. So you may put in some small mixer for the chemical mixing, for the flash mixing. That's the first point. Second point is your requirement for workshops. I think it all depends normally depends on the client. For smaller plants may not be requested, but for big plants, generally we will consider putting in a workshop and some areas for the operators to work on. Yeah.
Okay.
I hope that answers your question.
Yeah. Thank you.
But actually,
Sorry,
today's topic more on just a layout of the treatment plant. But if you have questions on any treatment design or treatment process you need, where I can answer or try to answer them. But I believe there should be other technical talk on the design of the treatment process unit, isn't it, Ruby? There'll be other chapters on filters, on clarifiers, and things like that. Yeah.
Zaina also stated here the treatment plant also requires lab tests for raw water and also treated water tests.
Require laboratory test for raw water and also treated water test. Yeah, I think that's definitely required. You mean in the laboratory there should be sampling from the raw water, from the settled water and filtered water and treated water. So normally they have 3 or 4 different types of samples from each point of the treatment plant to do a test. Is that what you're trying to say? Treatment plant also requires laboratory tests for raw water and also treated water. Yeah. Betul. So yeah, it's definitely required.
Okay, we have one more, Mr. Beh, from Ziwei Leong. Any guideline how many percentage capacity allowance contingency should be taken into account in the plant design?
Again, any guideline how many percentage capacity allowance contingency should I go in the plant design? Okay, this is what allowance. I think traditionally we design for 10 or 15% hydraulic overload on the structures, so that if you need to close down let's say in a process train, you have maybe 6 flocculation channels, 6 clarifiers. If you need to close one down, then the remaining one should be able to take the flow. On top of that, there should be the allowance of 10% of additional hydraulic capacity. 10 or 15%, I think. That can be confirmed when we have the technical talk on the design of individual process units. I hope I answered your question, Mr. Leong.
There's another one also from Lau Chong Chu.
Any guideline for that? In recent years, a lot of designers trying to incorporate inclined plate system for clarifiers to reduce the plant size, increase the production capacity. What is your And then by putting in the inclined plate in the clarifier, also the clarifier need to be covered to prevent the dropping. All right. Okay, good question. But I think this is more towards the design of the treatment plant already, but never mind, I can still answer this question. I think my experience with inclined plates, actually to be frank, in my first job in Semambo, we already put in inclined plates. There's a grandfather version of the inclined plates, which is a horizontal flow inclined plates. Inclined plates definitely requires a much smaller footprint. And it also can be incorporated in existing clarifiers to increase the production capacity. So I think there's nothing wrong with putting inclined plates in the existing plant or in the new plants. And clarifiers, normally we don't cover them to because for sedimentation, I think as any occasional droppings of birds or leaves or things like that is not detrimental to the process. But for process like dissolved air flotation, where the thing is turned upside down and the sludge float on top, we would definitely cover the building to prevent any strong wind or raindrops or whatever to disturb the layer of sludge floating on top. Okay. I hope I answered your question, Mr. Long.
Another one, Mr. Beh, from IT. Any guidelines for the land area required versus plant capacity in Malaysia? Any study from MWA?
Oh, as I said just now, the table 7.1 is a very old guide already. So definitely we would like to see some new guide. So I was hoping somebody from maybe MWA can take the initiative to start a small committee to look into this and look at the big plants that has been constructed lately, some bigger plants, and look at their area, the occupied areas, and come up with some rough guidelines as to how big the land will be required. But as I say, it is only a guide, depending on treatment process. Some treatment process will require much smaller footprint, or like Labuan Dagang, where they are treating water from Sungai Kelang, then they need a lot of additional process, or a lot of other advanced process, ozone, this and that. So they may require a bigger footprint. So it's not cast in stone, this sort of thing. So you have to, depending on case by case basis.
Next one is how the sludge pond and high level tank consider in the WTP layout design.
How the sludge pond and high level tank. I can understand the sludge pond, but I don't understand what you mean by high level tank. Consider in the treatment plant layout design. Yep. I think now we don't call them sludging, we call them residuals. So the water treatment plant residuals treatment has to be considered for new plant design now. And if lands are available, then we may still go for the sludge pond for temporary storage of the residuals and for natural drying. But for bigger plants, we now prefer the mechanical type of dewatering the residuals. So all this has to be taken into treatment plant layout design, definitely. I'm not too clear about your high level tank, the term used, so I can't answer that, sorry.
Okay. So Zainal here also said the plant also require elevated elevated tank, Mr. Beh.
Wash water tank, yes. Traditionally, as I say, the wash water tank are placed either on top of the main building or have a separate elevated reservoir type for backwashing of filters. But for bigger plants now, they are using backwash water pumps and drawing water from a wash water tank separate from the clear water tank. That means before, normally at the end of the filtered water channel, there will be a additional tank provided to store the backwash water. So from there, they use pump to pump for backwashing. That because for these questions on the backwash, an elevated wash water tank, as your water drops, the pressure could be slightly different. So whereas if you are using a pump to backwash, you have a more consistent pressure for backwashing. So that is the consideration.
Right. Next queue is from Amiro. Do all treatment plant need sludge treatment system? Is there any guideline to refer?
I think that one is a bit because at the moment, I think for new treatment plants, for all new treatment plants, we would prefer some form of residual treatment system to be incorporated in the design. Yeah, we do not allow any direct discharge anymore. That means your backwash water direct discharge to the river course. That is not acceptable now. So there will be a separate talk on section 14, I think, on the residual treatment. Perhaps we can discuss more in depth during that talk. Yeah, on the residual treatment.
Okay, I see here from the screen, Mr. Z is raising hand. Mr. Z Wei Leong, do you have any more questions? No, okay. Okay, I think that's for the question we received now, Mr. Beh.
Mr. Beh,
Mhm.
Mr. Beh, Zulfikri from Taliworks.
Yeah, Cik Zul.
I just to share some experience that the operators face lah. So maybe can be incorporated. I think maybe already incorporated or maybe not yet. First, I think our experience in Sungai Buloh last time, Sungai Buloh dam. So actually, what happened is that when we asked for release from the Sungai Buloh dam, and the water actually did not arrive at the treatment plant. Then what happened is that the Sungai Buloh river itself actually cannot cope with the release from the reservoir, from the dam and flooding there. So then I think maybe this one of the things that we the designer should look at when actually designing the dam, and look also at the river that receiving the release. I think maybe that river is too shallow or too small. Okay, that's one. The other thing is on the, I think just now mentioned about the distance between facilities. I think based on our experience also, maybe the designer should look at the between aerators and mixing tank also need to be some there's a suitable distance lah, because I think what happened is on our experience that if the distance is not sufficient, we have problem with the flow meters lah. Flow meters, because I think maybe what they call it, the disturbance lah.
Turbulence.
Turbulence, yeah. Then you have to put in all the other. We have to do something there. We put in all these to reduce the turbulence lah. And the filter itself, based on, I think this experience at the Semenyih also, and so that the Sungai Selangor. I think the weir actually, the weir going to the, when we going to the filters, the inlet to the filters, actually it should not be the same actually, because our experience actually, as you know, the hydraulic, because at the end there actually the water maybe actually less compared to the one at the middle when they're entering the filter channel there. So what happened that the filter in the middle will get more water, and then I think that one maybe then head loss is greater there lah, and the filter that is so far from the inlet getting less, so the head loss is less there lah. Then I think maybe this is the thing that the designers should look at to ensure that the water is distributed at almost the same to all the filters lah. Because I think as everybody knows, the filter head loss is the function also of the inflow.
Yep.
And then the other one same about the distance also. The distance between the clear water tank and the pumping station, treated water pumping station. I think this last time is probably at the Semenyih lah, but I think it's solved at the Sungai Selangor. But I think maybe just to remind that there must be a suitable system between the clear water tank and the pumping system. I think the Semenyih last time have problem of cavitation lah, because this the distance is too short. And the other one, I think this one I think we already discussed lah. I think on the pumping system must have two distribution, because we don't want that we want to we have to close down all the plant because we want to repair one pump only. So I think this is the thing that I think the designer need to look closely at, and also at the pumping system, because I think there's one plant I think maybe I should not mention. So I mean when we run 1 big, 2 big, 3 big, is follow the pumping curve, pumping system curve. But when we go to 4, 5, we go out of the order, and actually we get less than the design flow. So this is the thing that I think maybe everybody should look at it. So that's it, Mr. Beh. Thank you. Just to share my experience.
All right, thanks. I think you mentioned about the river downstream of the dam to the treatment plant. Definitely, I think designers should look into the carrying capacity of the river. Otherwise, you design too big a treatment plant, but the river cannot carry. There's no meaning. There's a missing link there. I agree with you. Designers should properly study the carrying capacity of the river and see whether you floods if you release the required amount of water. Yeah. The second one, between aerator and mixing, you're talking about the turbulence that caused the disruption to the flow measurement. I think it depends on the flow measurement. You are using the what you call sensor type of a flow measurement, or the piezo type.
Magnetic flow meter.
Magnetic flow meter in the pipe. It's in the pipe.
Yeah.
In the pipe. Oh, okay. In that case, I think the design of mag flow meter will have definite requirements. So many diameter upstream, so many downstream. That condition must be met. If you cannot meet that, then definitely there will be problem with your reading. So I agree with you. Designers should look into the straight length required. Yeah. If it cannot be too short. If it's too short, then they may have to think of other method of measurement. You can't use your mag flow meter anymore. Yeah. The question of a flow into the filter, that was definitely a valid comment. Normally we design, I think from most of my design, we have a clarifier straight into a what you call settle water channel, and from the channel there'll be it has to be some look into the distribution, the flow of the water into the filter. Like you say, it cannot be from one point at the center distribute to maybe 4 or 5 filters on each end. Of course, the last filter will get less water. Some people design with what they call a tapering channel. That means as you go towards the end, it taper towards the end. That means so that the last filter will receive almost the same amount as the center one. Yeah. Or you have two more entrance point. That means you enter at the quarter point, so that the difference in the inlet flow is not significant. If you get what I mean. I mean, you cannot enter at the center. You got to enter at a few more entry point, so that the flow can be equalized as far as possible. Yeah, that's a very, very valid comment. The clear water tank and treated water pumping station, cavity station. That is something. I'm not a mechanical engineer, so I think that can be further discussed when we talk about the detailed design of the treatment plant. You're saying clear water tank to treatment plant, to water pump station too short, is it? It caused a cavitation problem. Yep.
Yeah. Well, okay. That one was I was in Semenyih. Yep.
I see. Okay. We'll take. I think the designer should take that into account. Yeah. Okay.
Mr. B, I think there's one more on here for chemical storage house. How many days storage considered?
This one is more on other details. I think previous guide the old GKR guide will ask for 3 months, if I remember correctly. Definitely they will ask for 3 months storage, but be reminded that that was how many decades ago already. See, so now with a more efficient transportation and whatnot, chemicals can be delivered to the plant. If you make a phone call, probably within a week they should be there. So I think the new requirement probably asks for 30 days. 30 days will be sufficient, especially for hazardous chemical storage like chlorine and whatnot. It can be, 30 days should be sufficient, unless there's some catastrophic emergency that the plant production cannot cope or what. Then you may have problem. But I think 30 days should be sufficient. That's my personal view. Can I have the presentation slide? Yes, I think presentation slide will be given to MWA. Yeah.
Mr. B, I think maybe the local should be 1 month, but maybe you should look at the one that chemical that we import.
Oh.
Then 1 month maybe too tight.
Yang chemical yang apa tu kena import ni?
I think I don't know about others lah, but sometimes fluoride, I think you still import.
Fluoride. Okay.
I think maybe polymer also.
Oh, okay.
Others, I think we hear.
Good remarks. Maybe like imported. Yeah, like you say, if it's imported, then of course, if we may want to, Otherwise, any disturbance in the global transportation, then you got problem. Oh, yeah. True.
Any more questions? Anything you want to summarize, Mr. B? I think we should end quite early also today.
Yeah.
And okay, I think give you time to summarize everything. If you have anything last to say, and after that, I will share a bit on the upcoming program of MWA.
All right. Okay, so this chapter, as I say, is on the treatment plant layout and arrangement. But we have some interesting exchange on the detailed design of the treatment plant as well, which is good. We hope to have more active discussion like this, so that we can hear. Because as a designer, we don't have much follow up on the operating experience, and it's always good to hear from the operator what are the shortfalls, so that we can improve in our future design. Yeah. So thanks for your participation in this exchange.
We have one more question, Mr. Beh, from Boon Heng Yu. Is there a requirement to upgrade existing plants without residue treatments?
Is there a requirement to upgrade existing plants without residue treatments? When you say upgrade, do you mean upgrade on the capacity of the plant? Is there a requirement? I'm not quite clear as to when you say upgrade. For plants, I understand, for plant without residue treatment, you are saying, is there a requirement to upgrade? You mean okay, is there a requirement to upgrade so that to incorporate the residual treatment? Okay. That one I'm not too sure whether it's definitely compulsory now to incorporate residual treatment or not. I think that one we have to leave it to the
should be compulsory because
yeah.
because you cannot just throw away the
direct discharge. Yeah.
Because now I think they are going down to all the operators.
Yeah, and I believe the operator will wait until they get summons from DOE that they will start doing this for smaller plants. But for, I think I get what you mean. Some it will actually is quite necessary to incorporate the residual treatment now, because you don't want to pollute the river sources. Yeah. So all treatment plant without residual treatment should seriously look into upgrading to incorporate this residual treatment facility. Yeah.
Okay, I think that's about all the questions that we have for today. So allow me to share some information on MWA upcoming program before we leave. Hold on, yeah. All right. So this is today's talk by Mr. Beh. Thank you, Mr. Beh, for sharing your information and knowledge
You're
on this
welcome.
topic. Yeah.
You're welcome.
So I mean, this is not end here. If we have any more,
Yeah.
demand for the topic, then we will call you to present again. Okay. Okay, next one. Okay, this is the book that we have, volume 2 of MWA Planning Guidelines, Best Practices Handbook. Volume 2 comprised of section 14 to 27, so it's currently on sale. Members can get it at 120 ringgit per copy, and non-member is 180 per copy. You can get it at MWA office, or we can send it via courier with the extra charges. All right. Okay, this one is the upcoming collaboration webinar on groundwater with Pengurusan SNI Berhad. This information will be posted soon. The date is on the 16th August. On 16th August, 10 a.m. About 2 hours presentation. Yeah. All right. Okay, next monthly tech talk similar like this one, series 7 on water safety plans and drinking water quality management. This also will be posted to members, and more available information will be at the website and MWA Facebook.
Ruby, sorry,
Yeah,
interrupt sekejap.
sure.
Bawa series 7 sana, section, it's not section 7, I think. It should be a certain section number for this water safety plan.
Mesti dia
Yeah,
tak
so silap
update ni.
sikit ya.
Sorry.
Yeah,
Yeah.
it's
I
okay.
think we will update this.
Uh-huh.
Joe, take note on this, Joe. Okay.
Sorry. Sorry again. Apa tu sebab saya tak on call tadi?
Tak, this one is not section 7 lah. Nanti you betulkan topik dia is not section 7.
Oh, okay. So section
Tapi the title tu betul lah, water
Betul.
safety plans
Yeah.
and drinking water quality management by Dr. Hafizah Hassan from MOH.
Okay, sure.
Alright.
Alright.
Okay, next one is my water fund challenge. This program has been publicized for quite some time lah. I hope members and participants can join our program. So the challenge period already start from 1st July and will end on 31st of August. Okay, I've shared the link just now for you to register. Okay, this is a collaboration event as well, seminar on water 4.0, reaping the benefits of water 4.0 through skills development insights from the Malaysian water industry. This we are collaborating with UniKL. The date will be on 21st September and the venue will be at UniKL Bani. Okay, more information will be posted out. All right. Okay, this is the specialized conference, water quality and treatment. We have started discussing on this with the committee. So we'll information will reach you out on very soon. And the event will be on 15 to 16 November, venue at Pullman, Kuala Lumpur, Bangsa. Right. And this is MWA publications. Is an annual publication, a collaboration publication between MWA, SPAN, and also Water Division CASA. We publish it on yearly basis, comprised of data statistics, benchmarking, and reports on water and wastewater. So information, we target this to be published by September. So we welcome advertisement as well as if you want to pre-order, you can do so. Information is available in the website. Okay, and this one is MWA upcoming Water Malaysia Bulletin. Is a quarterly bulletin. So this upcoming issue will feature a story on pengurusan asset air on the theme is financing sustainable water services in Malaysia. All right, we encourage members, companies to advertise and support this publication. This publication is actually distributed to some of the government and ministries, department, and then to high learning institutions, financial institutions, and to MWA's overseas associates as well. Okay, you also can contribute your technical article, share with us any new technologies and applications, so we welcome so much on your support for the advertisement and editorial, right? This will be out for September issue, yeah? Okay, as you can see on the left, there are 2 past issues. Okay, this one is the calendar, 2023 desk calendar, MW also published this. Invitation will be out soon for members and companies who want to advertise. Right. The proposed theme is today's innovations for a sustainable tomorrow. Right. I think that's about it. Okay. I think we should end our session today, Mr. Beh and the rest. Before that, maybe we can take a group photo again for those who latecomers just now. Can can you switch on your video? Okay, I need Joe to help to take photo, Joe.
Okay. You
Take by
it
batch,
again,
yeah?
Okay.
Okay.
Right. We have our 4 page now.
Okay.
All right. Okay, ready? 1. Oh, hold on, Carol, switch on camera. Okay, ready? 1, 2, 3. Okay. Second page. Ready? 1, 2, 3. Okay. Third page. Okay, ready? 1, 2, 3. Hold on. And then last page. Last page, page 4. Okay, ready? 1, 2, 3. Okay.
Okay, thank you all. Thank you, Beh Hong Lin, the speaker today, for sharing your insights and also knowledge on this topic. And thank you to all participants for your participation and support to MWA's event. We hope to see more participation in our future program. So if you have anything, any ideas you want to share, any contribution on the publications advertisement, please do call MWA Secretariat, yeah? Okay, I hope take care and we'll see you next time. Thank you. Assalamualaikum.
Salam. Thank you.